Let's go to equal number 191, number of 1 bits. For this question, you give an n, and let's return the number of bits. For example, number 3 to represent as this kind of binary string. So there are 3 1 bits, so it counts as 3. In order to do this question, let's go review this kind of bit manipulations. We know 1 and 1 equals 1. 1 and 0 equals 0. And 0 with a mutual 0 and 0. It's there. Also, let's say 1 or 1 equals 1. 1 or 0 equals 1. 0 or 0 equals 0. And 1 XOR 1 equals 0. 1 XOR 1 equals 1. And 0 XOR 0 equals 0. So this is the basic manipulations. And also, this is the first thing we want to review. And the second thing we want to review is that if we want to check for a number, if the GS bits of this number is an integer or not, we can say if A in the I left shift J down equal to 0, right? So this you can check if this number for the J's bits is 0 or not. So of course we can this is integer, right? We can do it like this way to have a for loop for 32 bits. Let's try to see whether then do the counts. So this is the so let's review. This is first is the basic operation. Second is check this it is 1 or not. Third, we want to review is that the union of A B it is actually A or B. Okay. What does that mean is that, for example, we have A 101, right? 1010, and B we have 01 0 1. Okay, so the union AB will be 1 1 1 1, right? Because if we have this, we can this, right? That is also A or B plus G. So this is a union. The fourth things we want to review is that the intersection of A and B, that is A and B. So what does this one mean? So let's still use this example. So A and B, so this one is common, right? So that will be equal to 0 0 1 0. The fourth, the fifth thing we want to check if B is a subset. So what does this mean is that we want to check if its intersection is B, right? So that is A and B equals B. Then what's the B is A in the subset. And the sixth thing we want to review is that we remove B from A from A equal remove B from A. Okay, so that is for example, if B is a subset, right? So in many cases, we want to say, for example, many of the cases in BitMask, the dynamic program will check if the B is a subset. If it is, then we want to remove this kind of state. So we'll use a XOR B, right? And the seventh, we want to review is that remove the last one bit from A. Okay, so that is A and XOR A minus one. Okay. So what does this one mean? So this one means, for example, we have A, right? That's A, so 1, 0, 1, 0. So after we XOR X minus 1, we'll get, so X, well, let's see, X minus 1 is actually 0, 0, 0, 1, right? So if we XOR it, so what we get is, it is X 0, 0, 0. So that is remove the last one bit. The eighth thing we want to review is that so actually the eighth thing is that we want to count we how many ones? Just this question, right? So we can use this kind of just this question. We can use this kind of for loop. So I'll write this is for in the I equals how many ones, right? I equals n. I done the equal to 0. I n equal to I minus 1, right? So we have count there. So that means we keep in removing the last one bit and check it there plus plus. Then return count. Yeah. So the nice thing we want to review is that we can, for one state, enumerate all substate or state. Okay. So how can we do that? Is that we'll say for int I equals k, I down equal to 0. Okay. So um so this depends, right? So you can also greatly equal if you want to include 0. Then we'll have I equals I minus 1 and 8. Okay. So doing something, right? So what does this one mean is that, for example, we have A equals 1, 0, 1, 0. So it will get for example, it will get so I minus 1. That is 1, 0, 0, 0, right? And also this one minus 1 again, that is okay. So it will get the first state, right? The second state is 0, 0, 1, 1, 1. And if we end this, that is get its intersection, right? So that is 0, 0, 1, 0. So let's say these two states are the subsets of the substate of this kind of scenario, right? So this is what we want to review. And this question is kind of simple actually. We just use count it's an number of 8. Sorry, this is not a whole. This is the end. Okay. And so yeah. So this is a question. Okay.